This is 9.8 power series. Now we're gonna turn into something new. Instead of testing the series, we're gonna have a different type of series we call power series. So any series that have the power functions in it. To be precise, I'm going to give you an example here. When we talk about the power series, it means we have include some variables in it. Okay, so for example, we normally have some series that have 3 over n, right? Something like this, so 3 over n squared. But now we have the n powers to some unknown value, say it's x minus 2. Okay, so this series is called the power series when it has an n power. Normally we have a constant, right, 4 to the n or something, but now we have introduced the unknown variable x there. Then this is a power series that we want to investigate whether the series converges and diverges. Okay, so here's the definitions. A power series is said to center at x equal a is a series given by this form. So you have the segment notation, that's c sub n. So that basically is any functions of n. And then you have x minus a to the n power. X minus a to the n power. So if you write out explicitly, that will be, you see that will be 0 power, so it can be 1. Yeah. First power, second power, and third power. So you see that it's really the powers of the x minus 8 increase each time. Okay, so it is actually we call a generalized versions of a geometric series. Okay, so if you recall in geometric series, when you have, so let's say you have 4 times 3/5, okay, to the n power, and from 1 to infinity, or maybe from 0 to infinity. So what happened is when you have geometric series like this, when you write out explicitly, you see that the 3/5 is going to be start with 0 power, right? And then the next one is 3/5 to the first, and then you can have the 3/5 to the second, and etc. Right? So that's increasing. So you see that he have been pretty much the same, right? So if I have a series where you have say 4 here, and now I'm introducing x. Let's say you have x minus 2 to the n. Then what happened is, you see this quantity, it's the same, right? X minus 2 is to 0 power, then is to the first power, and that is to the second power is increasing. Now, this is still a geometric series because I multiply x minus 2 basically to get the next term, right? If I change the formula a little bit, instead of 4, let's say you have 4 over n. Maybe you cannot do n here because it's going to be 0 at the bottom. How about 4 over 1 plus n, right? Now, that'll be more generalized version of the geometric series, because now not only you multiply, right, each time you get the next term in terms of the x part, but then that's also changed when n equals 0 is 4 over 1, then it's 4 over 2, that's 4 over 3. So these also changes. Okay. So When we have a series of that form, it's called the power series centers at A. In this case, we say the series centers at 2. We're going to talk about the terminology later, is why we said it's centered as 2. Now, when I give you this new series here and say I want to know where the series converge or diverge, okay, so what should we do? We're going to use the ratio test to do. So recall, ratio test works well when you have the functions or the terms that stands the n powered exponential, or when you see maybe there's some factorials involved. So because of the natures of these power series with the n power, so the ratio test worked really well. Okay. So let's look at this one. Determine the convergence of the following series. Okay, so x minus 3 to the n powers over n. Okay, over n. So first of all, don't forget that this is a power series. Okay, so this is the power series. And where is the centered? You see x minus 3 to the n, so the 3 is the a. So this power series center at 3. Again, I will come back to terminologies after we finish this problem. All right, so what I'm going to do is I'm going to use the ratio test. Okay. Again, the ratio test you're going to see works well. It works really well. Okay. With the, let me erase this, I don't think we did that there. So recall when you do the ratio test, you take the limits of the ratios of a sub n plus 1 over a sub n, right? So we're going to do the limit of n approach infinity in absolute of a sub n plus 1 over a sub n. Right, so this quantity is a sub n. Okay, so if you take the limit and approach infinity, the absolute values, what is a sub n plus 1, right? Replace n with n plus 1. So that should be x minus 3 to the n plus 1 over n plus 1. All right, so that is my a sub n plus 1 divided by a sub n. Now, instead of divide by a sub n, I can multiply by the reciprocal of a sub n, and that is n over x minus 3 to the n power. Okay, then I can simplify from here. You see x minus 3 to the n plus 1, x minus 3 to the n. So the 2 got canceled, and you have x minus 3 left. Okay, x minus 3 left. All right, so it's still in absolute values. Now, n and n plus 1s are positive. Okay, so I probably don't need the absolute values for n and plus 1. But I'll leave it there. So let me rearrange it. How about n over n plus 1 together time this is an x minus 3 and approach infinity. Now watch, as n go to infinity, what is this quantity approaching? They are the same power top bottoms. So the ratio of leading coefficient E is 1 over 1. So that approach 1. It's approach 1, and it's going to be 1 time at x minus 3 in x in the absolute value. So that will be absolute values of x minus 3, right? X is the unknown, but it's constant, though it's not increasing, right, as n goes to infinity. So we got this. Now questions. Then does the series converge or diverge after we do the ratio test? Now recall in ratio test, what do we know? If the limit is smaller than 1, converges. Bigger than 1, diverges. Equal 1, not luck, I don't know, right? Unknown, inconclusive. So the question is, after take the limit, I got 1, but it's not really 1 times this quantity. So does this quantity less than 1? Well, the answer is, you don't know, right? Is it less than 1 or greater than 1 or equal 1? You don't know because it depends on what values of x is. If x is 3, say, then it'll be 3 minus 3 is 0, and certainly smaller than 1, right? You see that here we have quite a few possibilities. Well, not quite a few, but there's infinite many possibilities. The x is the one that we don't know. So let's say, again, just playing around, right? If x is 3, then what do we have, right? 3 minus 3. So your limits now called L. Okay, so the limit now is 3 minus 3 is 0. So 0 and smaller than 1. And we know the series then converges when x equals 3. Now let's say if x is 1, what do you think? If x is 1, then 1 minus 3, negative 2. Negative 2, absolute negative 2 is positive 2. So the limit is now 2, and 2 is bigger than 1. What do you say? If the limit is more than 1, the series diverges when x equals 1. Again, you can continue to explore if you want. How about if x equal 0, right? If x equals 0, then you have, I think L is now positive 3. It's bigger than 1 and still diverges. Okay. So now the problem is, does the series converge or diverge? Well, the answer is no, depends. It depends on x. But so the goal here is I want to identify all the x values for which is converge or when it's diverge. I know that x is 1 converge, diverge, 3 is converge, 0 diverge. So can you give me all the values of x where it converge? Okay. Now, of course, I cannot just plug and do this. It's going to take forever. So we're going to go back to the solving inequality, right? So in order for the series to converge, the limit here had to be smaller than 1. Has to be smaller than 1, right? So if this quantity, whatever the quantity is smaller than 1, the series will converge. So let's say if this less than 1, then what are all the x values? So you actually solve these inequalities. Now let's recall, when you have absolute of x minus 3 less than 1, do you remember this equivalent form? Right? So if absolute of x minus 3 is less than 1, it's equivalent to x minus 3 less than 1 or greater than negative 1. Okay, so x minus 3 is between negative 1 and 1. And then you can solve this inequality from here. Add 3 on all sides. You should have 4 over here and 2 over here. 4 and 2, right? At 3 minus 1 is 2. So now I have kind of the partial solutions to it. What do I mean partial solution? Is now I know if I draw the number line, he is 2. All right, so let's say go by 2. So that is 4 here. All right, so that is 1 here. It's 3 there. Now, what I know is from if x between 2 and 4. Okay, so if x is between 2 and 4 t between 2 and 4. Then you plug in, it should be less than 1, and then your series that we're testing will converge. So that's why you see here's when x equals 3, it converge because 3 is here. So any number x between 2 and 4 will make a quantity smaller than 1, therefore it would converge. Okay? Now, otherwise, if x is less than 2, if x is less than 2 or bigger than 4, what happens, right? If it's outside the interval, strictly it's less than 2 or strictly bigger than 4, then this quantity is going to be more than 1. You see here, when x is 1, or when x is 0, 0 evens out here, right? So if it's going to be less than 2 or more than 4, the quantity here is strictly bigger than 1, and therefore it would diverge. Okay, so see diverge and diverge. Now the question is still, what happened if x is 2? Don't forget that when x is 2 and when x is 4, if you plug in, 4 minus 3 is 1, right? So after the 1 is precisely 1. So when we are at 2 or at 4, is 2, 2 at 4, then the limit is precisely 1 by the ratio test is inconclusive. So that means from the ratio test, what I can tell you is, if x is between 2 and 4, converge. If x is strictly less than 2 or strictly bigger than 4, it will diverge by the ratio test. At the endpoints, when x is 2 or when x is 4, I have no clue. Okay, ratio test doesn't tell us anything. And therefore, when you use ratio test for these problems, we have to have a extra test to check the endpoints. Okay, so now I'm going to checking at the endpoints here. So what happened at x equals say 2, okay, at the endpoints, this endpoint, that what happened in x equals 2. Now if x equals 2, if you plug in here, what do I know? The series become, actually there's no x anymore, right? X is 2. 2 minus 3. 2 minus 3 is negative 1. So end up with negative 1 over n, and from 1 to infinity. Right? So you have a series without an x. We're going to test the series. Does it converge or diverge? Well, if you look back, this is really the alternating series. I think we have done this example back in the alternating series sections. This one, I'm going to skip the detail, but you should check. This is converges by the alternating series test. So yeah, I can have to do that. Right, so remember we have alternating series. You look at the b sub n. B sub n, in this case, you ignore the negative 1 part, is 1 over n. Then you check what? You check the limit, 1 over n, and approach infinity. Does it equal to 0? And then 1 over n plus 1 is less than or equal to 1 over n for decreasing. These two satisfy, so it converges by the alternating series test. So yes, at 2, the series converge. How about at the other end, right? So what happens at x equals 4? When x equals 4, again, you plug in 4 minus 3 gives you 1, 1 to the n power, right? So it's going to be 1 to the n, or just 1, right, over n, and n from 1 to infinity. Now, does this series converge or diverge? Well, that one is easy. It's a harmonic series. So it diverges by harmonic series. Okay, so that will be, or you can say P series with P equal 1, right? So it's diverges. Now, from the conclusions here, what I can see is at 2, the series converge, at 4, the series diverge. So if we're gonna cross out the 4. So what I can conclude is, so on what interval does the series converge? Well, everything between 2 and 4, including the 2, I use the bracket, and excluding the 4 because the 4 diverges. So you're going to use the parentheses. Okay. So your answer will be, this is what we call the interval of convergence. Because we don't have an exact only 1 or 2 values, whereas the serial converter we have a lot of them. So you're going to end up with the interval. So we say the interval of convergence for the series is 2 to 4, including 2, excluding 4. So that's our answer. Now, if you look back at this example one more time, do you see the 3 in the middle of the interval? You see the 3 here? It's, you look at this as an interval, you can think, I usually think of that as a circle, and that might explain some terminology. Here you think of like, it's like a circle, right? So you see that the 3 is in the center, in the middle, and this is why the terminology comes from A, the centers of A. You see x minus 3, that number 3? Number 3 is at the centers of our interval, always. Okay, it's always 3, the middle. Now, then the distance from the center to the endpoint, right? You think of that as a circle. So this length is called the radius. In our case, the distance here is precisely 1. So we would say the radius of convergence is 1. Okay. Now this example, you'll see that our interval convergence is center 3 with the radius 1, so pretty short, right? So only value between 2 and 4 to make series converge, otherwise diverges. You might have example where the radius is very wide. So let's say it's going to be, instead of center 3, right, from negative 10 to positive 20, whatever. So it's going to be wide range, okay? So in fact, we have 3 possibilities here. This is the regular case where you have the center and then you have some non-zero radius, right? There are 2 extreme cases. One is when the radius is extremely small. So basically the radius is 0. So in that case, you only have 1 single point. So in that case, the series only converge at 1 single point. The rest diverges. Okay, that's one extreme. The other extreme is the radius here is actually the widest it could be. So you go all the way positive to negative infinity, right, on both sides. In that case, the series converges everywhere, right? So it doesn't matter what values you choose for x, it will converge. Okay? It will converge for the entire interval, real number system. Okay? And then it never diverges. Okay, so that leads to the following 3 possibilities that I have just described. Given the power series of the form, okay, c of x minus a to the n power, there are 3 possibilities. One, the series converges only when x equals 8, at the center only. In that case, the radius convergence R is considered to be 0. The second scenario is the series converges for all x. Okay, so x between negative and positive infinity. In that case, the radius convergence R is infinity. The 3 is the one that we've done, so that was the regular case. there is a positive number r such that the series converges if x minus a less than r and diverges if it's bigger than r. So the r is really the radius of convergence. Okay. Then you see that we solve the inequality to get the interval. In our case, what is r? R is 1. Okay. Then be sure to check the endpoints. Okay, so you use ratio test, and you test at the endpoints as well. Now um, the interval on which a series converges are called the interval of convergence. Okay, like I said earlier. Now, if we regard the series as the functions f of x, the series of convergence is really the domain of f of x. So think about this way. Instead of think of that as a series, if I could define or regard it as a function, have this function f of x, then the function has the formula. What's the formula? A little bit weird. Let's say here's a formula for the function x minus 3 to the n powers over n from 1 to infinity. Okay. Now, what happened is, if you think of that as a function, remember you have the input, output, right? The input's x, and there's an output, right? We can do that. Now, the problem is, with these functions, you may not have what the domain is not as simple as you think, right? Normally, I give you the functions, say f of x is x squared over x plus 3, and then you say, all right, so I know that the domain is all real number except -3. Why? Because I can plug in anything I like. I just cannot plug in -3 in because -3 in I'm going to divide by 0. So the function is really undefined at 0, right? Now, likewise, here, how do you know which input x do not produce the output? Which one doesn't produce the output? Well, see, that's why I don't know, and that's what we're doing testing the series up here. Now, I know that when x is between 2 and 4, remember between 2 and 4, then the series converge. Converge means it has the sum. If it has a sum, that means it has the finite values. If you have, say, x equals 4, what's output? Well, if you have x equals 4, then you end up with this case. You see that it diverges. That would just mean it doesn't have sum. There's no output. What's 5? There's no output. 6, there's no output. Okay, so we've done that from 2 to 4. The series converges when there is a corresponding output because some exists. So in other words, the interval of convergence we found up here really the domains of this function if we regard that as the function. Okay. Right, so to finish part 1, I'm going to do examples in the part 2 of the video.